Welcome, everyone. Ready to dive deep into the world of aircraft assembly. Today, we're taking on the Aerospace Aircraft Assembly Standard. And let me tell you, this document is dense.
It's the Bible of aerospace manufacturing. Everything you need to know about building aircraft to the highest standards.
No pressure, right? So where do we even start with something this comprehensive?
Well, like any good construction project, you got to start with the foundation.
Makes sense.
And in this case, the foundation is understanding the language, the nuts and bolts, so to speak, of aircraft structures and terminology.
So we're talking about speaking fluent fuselage.
Exactly. This standard makes sure everyone's on the same page, using the correct terms for every part, every process, no room for ambiguity.
Right, because a wing is not just a wing. It's what is it,
A wing assembly, maybe with ailerons, flaps, spoilers, all with their own specific functions.
See, I'm already learning, but knowing the lingo is just the beginning, right? We've got to apply that knowledge.
Absolutely, and that's where shop mathematics comes in.
No, I'm pretty good at adding 2 plus 2.
This is different. We're talking about precise calculations, tolerances, understanding how even the tiniest fraction of an inch can make or break an aircraft.
High stakes math. The document really emphasizes how crucial accuracy is in this field. One wrong calculation and
Let's just say it's a lot easier to fix a mistake on paper than it is on a multi-million-dollar aircraft.
that's for sure. So we've got the language down. We're math whizzes. What's next?
Time to prove those skills. The standard introduces the NCAT level system, which ranks skill proficiency. The National Center for Aerospace and Transportation Technologies. They're the ones who set the bar for what it takes to work on these incredible machines.
So kind of like going for your pilot's license, but for, building the plane.
Exactly. You work your way up through different levels, each requiring more expertise and experience.
From apprentice to master craftsman, basically.
You got it. And this applies to everything, even using hand tools. We're talking specialized techniques, precise movements, understanding how the tool interacts with different aircraft materials.
So even something as seemingly simple as drilling a hole takes on a whole new level of complexity.
Think of it this way. You wouldn't use a hammer to drive a screw, would you? The same principle applies here. The right tool, used the right way, is essential.
I'm starting to realize that this document is all about sweating the small stuff.
Because when you're building something that's going to fly hundreds of people, thousands of feet in the air, there's no such thing as a small detail. Everything matters.
Rightfully so. But before we actually start putting things together, we need a set of instructions, right?
Blueprints, you mean?
Exactly.
Yeah.
But I'm guessing these aren't your average IKEA instructions.
Ooh, this is where it gets really interesting. The Aerospace Aircraft Assembly Standard dives into the intricate world of technical drawings.
Technical drawings. Sounds intimidating.
They can be, but they're also incredibly fascinating. Imagine being able to look at a flat sheet of paper and visualize a three-dimensional aircraft taking shape in your mind.
Like magic. Almost. But there must be some kind of code to crack, right? Symbols, abbreviations, all that.
Exactly. These drawings are packed with information, from dimensions and tolerances to material specifications and assembly instructions.
Talk about information overload.
Don't worry, the standard breaks it all down. It explains different drawing types, detailed drawings, assembly drawings, installation drawings, each with its own purpose in guiding the assembly process.
So it's like having a step-by-step guide, but a million times more complex.
More like 1,000, but you get the idea.
I'm starting to get it. But I have to ask, with all this emphasis on precision, is there any room for error?
Well, that's where allowance, tolerance, and tolerance buildups come in.
Tolerance. Like, as in tolerating a mistake.
Not quite. In engineering, tolerance refers to the acceptable range of variation in a part's dimensions.
So it's not about being perfect, it's about being perfectly within a certain range.
Exactly. Manufacturing processes aren't perfect, so there will always be slight variations in the parts. Tolerance ensures those variations don't compromise the overall integrity of the aircraft.
That makes sense. You can't expect every single part to be identical down to the nanometer.
Exactly. And that's where GD&T comes in, geometric dimensioning and tolerancing.
Okay, that sounds intense. Is this where I need my engineering degree?
Don't worry, we'll keep it simple.
Okay.
Basically, GD&T is a system that defines how those tolerances are expressed and interpreted on the technical drawings.
So it's like a universal language for engineers to communicate about acceptable variations.
Precisely. It ensures everyone involved in the manufacturing process is on the same page, interpreting the tolerances correctly to build an aircraft that meets those incredibly high standards.
Wow. From specialized language to precise measurements and tolerances, it's clear that accuracy is paramount in this field.
It is. Every action, every measurement has to be deliberate and accurate. Now, with a solid grasp of the blueprint, we can start talking about the materials that bring these designs to life.
This is where we finally get to bend some metal, right? Fire up the welding torches.
Not so fast.
Yeah.
While we still use traditional metallic structures, the world of aircraft construction is increasingly turning to composite materials for their unique properties.
Composite materials, like carbon fiber, I know that's used in a lot of high-performance aircraft. Is that what they're referring to in the standard when they mention advanced composites?
Precisely. Think of materials like fiberglass, carbon graphite, even aramid, the stuff they use to make Kevlar. These advanced materials offer an incredible strength-to-weight ratio, making them ideal for aircraft construction.
But there have to be some downsides, right? Why haven't composites completely taken over?
Excellent question. The standard points out that working with composites often requires specialized tools, training, and safety precautions. They can also be more expensive than traditional materials, and repairs can be more complex.
It's a balancing act then. Strength and weight savings versus cost and complexity.
You hit the nail on the head. It's a fascinating trade-off that engineers are constantly trying to optimize. But whether we're talking about metal or composites, one thing remains constant: the need for meticulous precision at every stage.
Speaking of meticulous precision, I'm particularly interested in the sheet metal layout, marking measurements and spacing section of the standard. It sounds incredibly detailed.
It is. Remember those precise measurements from the blueprints we talked about? This is where they come to life. We're talking about the meticulous process of transferring those measurements onto the actual material, whether it's sheet metal or composite panels.
And I'm guessing a simple ruler and a pencil won't cut it at this level of accuracy.
You're right. The standard mentions specialized tools like prick punches, transfer punches, and even a hole finder. Apparently, using the wrong tool, even for something as simple as marking a point, can compromise the integrity of the material.
Wow. Who knew there were so many ways to mark a line or punch a hole?
It's a testament to the level of precision required in aircraft assembly. They even specify using ultra-fine point Sharpie felt tip markers for marking. It's all about minimizing errors and ensuring absolute accuracy.
It sounds almost like an art form, the way they focus on these minute details. It reminds me of those artisans who create incredibly detailed sculptures or miniature models.
It's a good comparison.
Yeah.
There's a level of craftsmanship involved in aircraft assembly that goes beyond just following instructions. You need a steady hand, a keen eye for detail, and a deep understanding of the materials you're working with.
It's amazing to see how much care and precision goes into every single aspect of aircraft assembly, even something as seemingly mundane as marking and measuring.
Absolutely. And it doesn't stop there. Before we can even think about assembling the parts, we need to address a silent but potentially devastating threat: corrosion.
Corrosion. You make it sound like a monster lurking in the shadows.
Well, in the world of aircraft assembly, it's a serious concern. Remember, these aircraft are exposed to extreme conditions: humidity, temperature changes, salt spray if they're flying near the ocean.
You're right. I hadn't thought about that. It's a completely different environment from your average car sitting in a garage.
Exactly.
Hmm.
And even the smallest amount of corrosion can compromise the structural integrity of an aircraft, which is obviously a huge safety concern.
So how do they combat this invisible enemy? What does the standard say about preventing corrosion?
It covers various methods, from using corrosion-resistant materials to applying special coatings and sealants. It also emphasizes regular inspections and maintenance to catch any signs of corrosion early on.
Sounds like they're taking a multi-pronged approach to stay one step ahead of corrosion.
Precisely. They even have guidelines for handling materials during a manufacturing process to prevent corrosion. Things like using clean gloves, storing parts properly, and even controlling the humidity in the workspace.
It seems like they've thought of everything.
Well, that's the point of a standard like this.
Wow.
It brings together decades of experience and best practices to ensure that every aircraft is built to the highest standards of safety and quality.
I'm starting to see that this standard isn't just a dry set of rules, but a roadmap to building machines that can soar through the skies safely and reliably.
Exactly. And now with the groundwork laid, the blueprint deciphered, materials chosen, and corrosion kept at bay, we can finally start putting these pieces together.
That's what I like to hear. We've covered a lot of ground, but the real excitement begins when we start assembling the aircraft. I can't wait to hear about the tools, the techniques, and the challenges they face in this final stage.
And you won't have to wait long. That's precisely where we'll pick up in the next part of our deep dive.
All right, the parts are prepped, the blueprints are deciphered. Let's start putting this aircraft puzzle together.
And just like any good puzzle, we need the right pieces to connect everything. And in aircraft assembly, those pieces come in the form of fasteners.
Okay, so not your average screws and bolts from the hardware store.
Definitely not. This is aerospace-grade hardware we're talking about. The Aerospace Aircraft Assembly Standard lays out the different types: threaded fasteners, blind fasteners, lock bolts, rivets, each engineered for specific applications and stresses.
I'm intrigued by those blind fasteners. The name itself sounds, well, a little unnerving when talking about aircraft assembly.
They sound counterintuitive, but they're incredibly useful. Imagine trying to secure a panel on the inside of a wing. You can't exactly reach behind it with a screwdriver, right?
Right, that would make things a bit difficult.
Blind fasteners are designed to be installed from one side, creating a secure joint without needing access to the back.
Ingenious. What about rivets? I always picture those being hammered in with a loud clang.
That's the classic image, isn't it? While specialized rivet guns have modernized the process, the basic principle remains the same. Rivets create a strong, permanent joint that can handle the incredible stresses aircraft endure.
It's amazing how much thought goes into each little detail. So we've got our fasteners, but how do they actually put everything together?
That's where the rubber meets the runway, so to speak. The standard goes deep on structural assembly, and this is where those meticulously fabricated parts, those carefully selected fasteners, come together with the skill of highly trained technicians.
So it's more than just connecting part A to part B. What else comes into play?
It's about creating a seamless, integrated structure. Think about drilling a hole. Seems straightforward, right?
Well, we know from our earlier discussion, even drilling is a precise process in aircraft assembly.
Exactly. The type of drill bit, the speed, the pressure, it all affects the quality of the hole, which ultimately impacts the joint strength.
So you don't just grab any old drill and go to town.
Not if you want your aircraft to stay in the air, you don't. Then, depending on the fit required, the hole might need to be reamed, slightly enlarged, for a precise fastener fit.
Wow, it's detail after detail. It's really amazing how much precision goes into each step.
It has to. We're talking about building machines that are going to be subjected to extreme forces and stresses, so ensuring that every joint is perfectly formed is critical.
Okay, so the hole is prepped. Now we bring in those specialized fasteners we talked about.
Exactly. Rivets, threaded fasteners, lock bolts, blind fasteners for those tricky spots. Each one has its own set of tools and techniques for installation, all meticulously detailed in the standard.
It's like a well-choreographed dance, with every movement planned and executed with the utmost precision.
A great analogy. Aircraft assembly is truly a testament to the skill and dedication of those technicians, because one small error at this stage could have huge ramifications later on.
Talk about pressure. Building an aircraft is a huge responsibility.
Absolutely. That's why this standard, this roadmap of best practices and lessons learned, is so crucial. It sets the bar for safety and reliability in an industry where those factors are non-negotiable.
It's like the standard is a safety net, guiding every step and minimizing the potential for human error.
And it goes beyond just the physical assembly. The standard also emphasizes quality control, safety protocols, even meticulous documentation of the entire process.
Speaking of which, the document mentions foreign object elimination and tool accountability. Like they're trying to eliminate any possibility of a stray tool or a misplaced bolt ending up where it shouldn't.
Exactly. Every single step is meticulously documented and inspected. It's all about ensuring nothing is left to chance when you're dealing with the complexities of aircraft construction.
So it's like a crime scene investigation, but instead of solving a crime, they're building a machine that can soar through the air.
That's a great way to put it. Attention to detail is paramount. Every aircraft that rolls off the assembly line needs to meet the highest possible standards.
We've talked about the precision of the assembly, but now we need to make sure this meticulously crafted aircraft can withstand the test of time. And that brings us back to corrosion.
Ah, yes, the invisible enemy. We've covered prevention during manufacturing, but as they say, the fight's not over till it's over.
So how do they keep those aircraft in tip-top shape, corrosion-free, even after they've left the factory floor? I'm ready to hear more about that battle against the elements. So we've built this incredible machine piece by piece, but then you send it out into the world, into the elements. How do you even begin to protect against that constant barrage?
It's a challenge, for sure. You got UV radiation, temperature swings, moisture, even those de-icing fluids they use on runways. It's a recipe for corrosion if you're not careful.
And we've talked about prevention during assembly, but it sounds like this is an ongoing battle.
Absolutely. The Aerospace Aircraft Assembly Standard dedicates a significant portion to outlining corrosion prevention and control methods for aircraft that are already in service.
So it's like arming them for a lifetime of wear and tear. What are some of the strategies they use?
Well, it starts with choosing the right materials in the first place. Corrosion-resistant alloys, composites, these are often incorporated into the design from the very beginning.
So the fight against corrosion begins on the drawing board.
Precisely. But even the toughest materials need a little help, which is where protective coatings and sealants come in.
Ah, so like a shield against the elements.
Exactly. Think of it as a barrier between the aircraft's structure and all those corrosive elements we talked about.
But I imagine those coatings wear down over time with all that exposure
That's why regular inspections and maintenance are absolutely crucial.
to catch any potential problems early on.
Precisely. Even a tiny little spot of rust, if left unchecked, can turn into a major headache down the line.
I can only imagine the kind of meticulous record-keeping that goes into all of this.
Oh, it's extensive. Every inspection, every maintenance procedure, it's all documented in detail. It's about creating a comprehensive history of the aircraft's life, so you can track any potential issues and address them before they become major problems.
It sounds like a monumental task, keeping track of all those details for such complex machines.
It is, but it's essential for ensuring the safety and longevity of these aircraft. And it's not just about having the right materials and procedures, it's about the people, too.
The technicians, the inspectors, the engineers, they all play a role.
Absolutely. The standard stresses the importance of training, ensuring that everyone who works on these aircraft understands the importance of corrosion prevention and control.
Because even the smallest mistake could have huge consequences.
Exactly. And that brings us back to the core of what this Aerospace Aircraft Assembly Standard represents. It's a commitment to excellence, a dedication to getting every detail right, no matter how small.
It's about understanding that when you're building something that's going to fly, there's no room for shortcuts.
Precisely. It's about striving for perfection in a field where even the smallest imperfection can have significant consequences.
Well, I'd say we've definitely gained a whole new appreciation for the level of detail and the commitment to safety that goes into every aspect of aircraft assembly.
And hopefully our listeners have too. It's a fascinating field full of incredible engineering and meticulous craftsmanship.
It's a reminder that sometimes the most extraordinary things are achieved through painstaking attention to the smallest details. Thanks for joining us on this deep dive into the world of aerospace assembly.